Welcome to our program, Astronomy for Everyone. For this evening's program, we're going to talk about the Cassini mission to Saturn. With me here in the studio is Steve Whitty, a member of the Ford Club. Steve, welcome to the program.
Great to be here.
Now, we're going to talk about the Cassini mission. Anything in particular about this mission?
Well, I gave this talk about a year ago. The Cassini mission the Cassini orbiter has been orbiting Saturn for a number of years, since 2004. So it's been orbiting now for about 7 years, and it took about 7 years to get to Saturn from Earth. So it was launched in 1997. So I gave this talk about a year ago at the Warren Club at one of their regular meetings. But that was an hour-long talk, and this is a half-hour show. So we're going to just talk about Titan. Titan is a very interesting moon. It's the only moon in the solar system, the only moon of any planet in the solar system that has its own atmosphere. And the atmosphere is very interesting on top of that because, like Earth, it's a mostly nitrogen atmosphere. Now, there's no oxygen like there is on Earth. That's because life generates oxygen, mostly plants, on Earth. What Titan has instead is methane and ethane in the atmosphere, and that's kind of interesting as well.
Because it's so cold there on Titan, obviously there's no photosynthesis as we know it here.
That's right. Saturn, and therefore Titan, is about 10 times as far away from the sun as the Earth is, and so it gets about 1/100th of the energy, the heat energy, that the Earth gets. So it's very cold.
We're looking at the range of about minus 300 degrees Fahrenheit?
Something like that, yeah. Minus 270, for example, is a good number. And it's a critical number, as it turns out. We'll get to it later. But it's a critical number because you would think that water would be frozen solid. In fact, planetary scientists thinking about Titan think of water as basically rock because it's so hard.
At those temperatures? At
those temperatures.
Now, you mentioned Cassini. Was Cassini the first mission to view Titan?
No. Pioneer 11 did a flyby of Saturn, and Voyagers 1 and 2 also did flybys of Saturn. Voyager 2 actually went by Saturn before Voyager 1 did. They were basically the same craft, and since Voyager 2 was so successful at investigating Saturn, they diverted Titan to, they diverted Voyager 2, I'm sorry, they diverted Voyager 1 to Titan to do a close-up investigation. That meant that Voyager 1 could not go on to see Uranus and Neptune, but Voyager 2 went ahead and did that, so we've got that data.
Okay.
It was a little bit of a disappointment because Voyager 1, when it used its cameras to look at Titan, it couldn't see the surface. The atmosphere is like a smog. It's very opaque. It's very thick. So you couldn't see the surface at all. So it did do some interesting measurements, but it didn't get us what we really wanted to know. We wanted to know what it was like on Titan.
So when we sent Cassini, we sent different type of cameras?
Absolutely. We sent a whole bunch of instruments. I think of Cassini, the mission, the spacecraft, as basically being a school bus. It's huge, and it's got tons and tons of instruments. Two of them that are really important, though, for looking at the surface of Titan are a special infrared camera. There's a small wavelength, small wave band, if you will, where you can actually see all the way down to the surface of Titan in infrared. And also, Cassini carries radar, so it sends radio waves to Titan, and then they bounce off and they come back, and Cassini can make a radar map in swaths, not the whole planet, but in swaths with high resolution, and they can get data from the surface.
Now, in addition to studying Titan from orbit with Cassini, wasn't there also a lander with that program?
That's right. That's right. Cassini carried a European mission, in fact, the Huygens lander. And the Huygens lander, it had its own little batteries. And the probe was dropped into the Titan atmosphere. The parachutes opened, and it made a soft landing on Titan. Now, since Voyager 1 didn't actually get to image the surface, people were wondering what they would see when they got there. And it might have been an ocean. A lot of people thought that this methane and ethane in the atmosphere would rain and create a big ocean, perhaps even a planet-wide ocean. And so they thought, well, we've got to be prepared for that. And the Huygens lander was prepared to land in a liquid or a solid. And so when it made it down to the ground, it turned out that it landed on a solid. It had the consistency of a sort of a fairly hard slush. But it was basically dry.
Okay.
And it looked like a lake bed. And in fact, as the Huygens lander was coming down to the ground, you can actually see in the images, you can see what looks like little river channels that cut into the edge of a dried lake. And so you have dried river channels into a dried lake, and Huygens lands in the middle of that.
Okay, so it's landed on a solid surface, but we have found that there are lakes on Titan.
That's right. With radar measurements, it turns out that so the radar isn't. You see images, but it's really data. The radar images tell you different things, though, than you get visually. What it really tells you is the texture of the surface that you've imaged, and it's very conspicuous in the data. You have these very, very smooth sections, and so the assumption is that they were lakes. But you would really like some sort of alternate data that confirms your suspicion, and it turns out that we got it.
Oh, okay.
So we had to wait for the geometry to change. We had to wait. So Saturn has an axial tilt like the Earth does, and so it has seasons like the Earth does. But since it takes 30 years to go around, it takes 30 years to go from winter to summer to winter, if you were like in the Northern Hemisphere.
Sure.
And so we had to wait until we went from illumination of the south to illumination of the north. And then on top of that, the Cassini spacecraft had to be in the right position, and they caught what's called a glint off of one of the lakes.
Much like a glint off of a lake here on Earth, right?
That's right. If you fly in an airplane over a lake and you look down by your shadow, you can often see a lot of light, a bright light, shining directly off the lake right back at you, right around the shadow.
Now, we were talking about some extremely cold temperatures, so glint off of liquid is not water. What is the liquid?
That's right. So the liquid is methane and ethane. It's a combination of these two hydrocarbons. Methane is a gas on Earth, but at these cold temperatures, it's often a liquid. And in fact, there are clouds of methane-ethane clouds that have been detected on Titan, and in fact, rain has been detected on Titan.
A methane rain.
That's right. Methane.
Not unlike the water rain
That's
we
right.
have here on Earth.
And so those river channels that were cut, that Huygens saw, were probably cut by some methane-ethane combination, and it probably filled that lake bed that Huygens landed on at one point. Now,
Yep.
the lakes that we see are either in the southern hemisphere or the northern hemisphere, and Huygens landed at the near the equator. So at the moment, we think of the equator as being basically a huge desert, if you will, cold desert, and the northern and southern hemispheres have these lakes. In the beginning of the in the beginning of the Cassini mission, the first 7-something years, we were in the southern hemisphere of Titan and Saturn were illuminated by the sun, and over the years, successive images, as Cassini passes Titan, successive images have shown the same lake getting smaller in the southern hemisphere. And
during their summer.
During that summer. Mm-hmm. And during that same time, the lakes in the northern hemisphere got larger. So presumably you had evaporation in the south, the clouds carry the methane, ethane up to the north, and it rains in the north, and the lakes there are getting bigger. The glint that was discovered earlier was this very large lake, which they call Kraken. It was discovered in radar data and then confirmed with this glint in infrared data. And this lake is utterly huge. It's 150,000 square miles. Now, this is a number that I couldn't really wrap my head around, so I said, well, what if it was a circle? It's not. What if it was exactly round? How big would it be? Well, it would be 400 miles across. You know, so that's like Detroit to Pittsburgh, maybe? It's quite a big area.
That's huge. That's huge.
So it's not just a Great Lake, it's just humongous.
Now, on Titan, it has a crust or a mantle, and with, I'm assuming, water ice and other ices. What else can we find on the inside of Titan?
Yeah, so Cassini, being in orbit of Saturn and making multiple passes at Titan, they can do something called gravity maps. And basically all they do is when they fly by, they're also sending radio back to Earth. And Earth radios pick that up, and you can very precisely figure out where the spacecraft is going. And as it goes by Titan, the various gravity differences from within the body, the object, deflect the orbiter a little bit. And so they have gravity maps of Titan. And from these gravity maps, you can actually figure out the structure. And the structure that we now understand has changed. We used to think that there was a rocky core, followed by an icy layer, followed by perhaps some sort of an ocean, and then a crust. That's the picture on the left in the image that's up. But from the Cassini data, it's quite clear that the rock and ice never fully separated. The rock would be heavier and fall to the center, but for whatever reason, the rock and ice never did fully separate, and you have
sort of an intermediate zone of rock and ice together?
That's right. You have a mixture of rock and ice. And then you still have an ocean layer, which we'll get back to, and then a crust, which is then the top of the crust is then the surface.
Do we see similar things in some of the other moons of our solar system?
Yeah, that's right. Two of the big moons of Jupiter, Ganymede and Callisto, have similar structures. And it's kind of interesting. And all three moons are very similar in size. Ganymede is the biggest. Titan is the second largest. Callisto is the smallest of the three. Well, Ganymede is just a little bit bigger, and it's a little bit further out from Jupiter than Callisto is. And so its inner core has been able to differentiate into rock as a separate entity, and then an ice layer, and then an ocean. Callisto, like Titan, has this mixed rock and ice. So it has to do with, for orbiting Jupiter, it has to do with how far from Jupiter they orbit and the interactions with the other moons.
So then the similar would hold true then for Titan, to a degree?
To a degree, we expect that, but there may be something more complicated going on with Titan. And if we have time, we'll get to that. It's kind of a funny story.